Hello again. In this session, we will discuss another example to understand impulse, and then we will look at the four fundamental forces and learn how all the other forces that we see are basically one of these four fundamental forces in different form. Right. So let's start with our example. Let's say that a ball of mass 1 kg is dropped from a height of 20 meters on ground. So when this ball falls on ground, obviously it will not immediately stop, but it will dig into the ground to some height. So say it is given that after collision the ball goes down to a height of 1 centimeter. Right. So what we have to find is, first of all, the impulse applied by the ground on this ball, and secondly, we wish to find the magnitude of the impulsive force. So we wish to find, first of all, the impulse that acted on this ball, and secondly, the impulsive force offered by the ground on this ball. Right. So let's first try to find the impulse that acted. Now we know that impulse is nothing but change in momentum. So since we are talking about a single particle, momentum is simply mass into velocity. Right. And change in momentum is nothing but the final momentum minus the initial momentum. Right. So after the ball has gone down by this height of 1 centimeter, it finally comes to stop. So if it stops, that means the final momentum is 0. So all we need to do is find the initial momentum of this ball. Now be careful while writing the initial momentum. We are not talking about this highest point. We are talking about the momentum just before the collision starts. So we need the speed just before this ball hits ground, because only after that the collision has started. It did not start during the while the ball was falling through air. It started just when it hit ground for the first time, that is, after it has fallen through a height of 20 meters. Right. So to do that, we know that the ball has a constant acceleration of 10 meter per second square, which is nothing but the acceleration due to gravity. So the ball has this constant acceleration. It was released from the top, that means it was given 0 initial velocity, because that is what releasing something means. If you release something, you're not giving it any additional velocity. So when you release it, you're giving that object 0 initial velocity. Right. So to find its velocity just before it hits ground, we can use the third equation of motion, because we know the acceleration, the distance, and the initial velocity, and we need to find the final velocity. So using third equation, first let's get to that. So for this interval, we will apply the third equation of motion, that is v square minus u square is equal to 2 into a into s. So let's now substitute values. The topmost point is the initial point, and this point just before the collision is the final point. Right. So the speed at this point is basically the final speed. So we have v square minus 0, because the initial speed was 0, is equal to 2 into 10 into 20. So you get that v is equal to square root of 400, which is 20 meter per second. Right. So if its velocity, or its speed rather, just before hitting ground was 20 meter per second, then the momentum, which we know is equal to mass into velocity, will be equal to the mass of this ball was 1 kg, so 1 into 20 becomes 20 kg meter per second. So this is the momentum of the ball just before it hits ground, and that is the same value that we need to substitute in this equation. So we have 0 minus 20, which is equal to minus 20 kg meter per second. So this expression gives you the impulse applied by ground on this ball. Right. So after having found this, we are now interested in finding the magnitude of impulsive force. Now, we know that impulse is equal to the change in momentum and is hence equal to force into time. Right. So we basically need to find the time it took for the ball to stop between hitting the ground and finally stopping. So basically we are looking at this interval and we wish to find the time between the ball finally stopping and it just hitting the ground. Right. So for this interval, let's think about the variables we know of. We know that just when the collision started, the speed, which would become the initial speed in this case. For the second interval, the speed is the initial speed, and we know the value is 20 meter per second. We know that the final velocity was 0. Right. What else is known? We know the distance through which it moved, which is given to be 1 centimeter. So we know that S is equal to 0.01 meters. So note that I have converted the given distance into SI units. So the distance is given to be 0.01 meters and we need to find acceleration. So once again we can take help of the third equation of motion. So once again we have V square minus U square is equal to 2AS. V in this case is 0, U we have found was 20 and U square hence becomes 400. This is equal to 2 into A into S being 0.01. So when you take these terms on the left hand side, you see that A is equal to 200 and you would have additional 2 zeros coming from 0.01. So this acceleration is equal to 20,000 meter per second square. So this is a very large acceleration, and once we have the acceleration, we can obviously find the force which acted. The force we know is equal to mass into acceleration. So 1 into 20,000 gives you the force as 20,000 Newton. So in this case, instead of using force into time to find impulse, we directly found the acceleration and hence arrived at the expression of the force. Right. Why we did that is because we already did not know the acceleration. So to find time, we would have to first calculate acceleration, then go back to the first equation of motion, which is V minus U is equal to AT. So using this, we could have calculated time and then use that value to calculate force by doing impulse by time. If you had done that, you would have gotten the same expression. In fact, I would suggest that you take that approach and check if you get the same answer or not. Right. So I hope with that example, the concept of impulse has become perfectly clear to you. Right. So let's now move to fundamental forces. So basically there are 4 fundamental forces, namely gravitational force, then electromagnetic force, the next is strong force, And the last one is weak force. So all the other forces that you usually see are basically one of these forces acting in a different form. And the most common force that we see is basically electromagnetic force. So let me explain each of these briefly. Let's start with gravitational force. Now gravitational force is a force that every mass exerts on any other mass. We will later study that Newton gave the laws for gravitation, and they tell us that any two bodies which have mass will attract each other with a force which is given by the expression, and I'll just mention the expression without giving you the details. So the force is given by G m1 m2 by r square, where G is a universal constant, m1 m2 are the two masses, and r is the separation between them. So any two masses which are there at a distance r attract each other with this force, and this force is there because the two bodies have mass. So this force is there because of the mass that these bodies have, right? So that was about gravitational force. Moving to electromagnetic force, we would see that this force can be broken down into two forces, which is electrostatic force and magnetic force. Now, electrostatic force is the force that stationary charges exert on each other. I'm sure you're already aware that like charges repel and opposite attract. So these forces that we talk about, this attraction and repulsion, these forces are electrostatic forces, the force that stationary charges are exerting on each other. Then you're also aware of magnetic force. I'm sure you've heard about magnets. You know how magnets attract and repel each other when you bring similar or dissimilar poles close to each other. So these two forces have together been clubbed into electromagnetic force. Now, all the forces that we studied about, namely tension, normal, spring force, even friction, all these forces are basically electromagnetic in nature. You can figure it out if you think about all these forces. So when we talk about normal, the force is exerted through contact. So what will happen when you establish contact? The two materials which are being brought close together, the atoms become very close to each other. So now atom, if you're aware, is made up of a nucleus and then there are electrons around it. So when they come very close to each other, they start repelling each other. And that is why if you push one object close to the other object is pushed further. Right. Same is the case with tension. So every object is made of a particular structure which is there because of all the charges that are present. So if you try to change its orientation, these charges get disoriented and then they try to restore their original position, and as a result create a force which is known as tension. The spring force and the friction have similar reasons which we will not go into the details of, right? The other two forces are called strong and the weak force. Now, these forces are effective only at a very short range, which is of the order of 10 raised to power minus 15 meters. This unit is also called Fermi. So 10 raised to power minus 15 meters is denoted by another unit which is called Fermi. This is because this is the order of atomic nucleus. An atom is typically of the size of angstrom, which is 10 raised to power minus 10 meters. So understand that we are talking about scales which are smaller than an atom. This is the size of a nucleus. So these forces are not significant at a distance which is more than the order of 10 raised to power minus 15 meters. Hence, these forces are only effective inside nucleus. We will later study how these forces play a role in radioactive decay of certain materials. Right. They are also the guiding factor in all the nuclear reactions. You might have heard about nuclear reactions. Nuclear reactions, as opposed to chemical reactions, are reactions where nucleus takes part. In chemical reactions, only electrons are exchanged. So these forces play a role when we talk about nuclear reactions. Right. So with that, we come to the end of this session. So in this session, we discussed mainly about these four fundamental forces and saw how these four forces are seen in different forms. Right. In the next session, we will talk about constrained motion. Thank you.